Hello, in this video, we'll be looking at solving equations that involves one or more radicals. The first step in solving an equation that contains a radical is to eliminate the radical from the equation. To do so, we need what is called the addition property. We have seen also that if we square a number on both sides of an equation, then that also, if we square and solve, then that will be a solution to the equation. But sometimes as we do this, we incorporate what is called an extraneous solution. Yeah. So if we know if A is equal to B, yeah, then A squared is equal to B squared. Yeah. All we did was square both sides. But as we do this squaring here, as we perform the square, when we square both sides, we may have what is called extraneous solutions. So it is very important that when you do square both sides of an equation, we will have to check it. So we never lose the solution to our equation by squaring both sides, right? We will never lose solutions to our equation by squaring both sides. So we never lose it. We may, however, introduce what is called extraneous solutions. And an extraneous solutions satisfies the equation obtained by squaring both sides of the original equation. But, and this is the important part, but do not satisfy the original equation. You will see an example of this, right? So let's look at this. For example, we know that 5 is not equal to -5. This is false. Okay. But if we square both sides, then we have a true statement. Okay. By squaring both sides, okay, then we have 25 is equal to 25. So as you can see, something that's false actually became true, right? This is a true statement. So by squaring, right? By squaring, we end up with a true statement. And that's what we have to be careful about. So all this really means to us is that you have to check your answer 100%. You must check your answers or answer, because you could have incorporated an extraneous solution, right? So that solution that doesn't work after you square is called an extraneous solution. So let's just jump right into this and let's do some examples. So example, solve for x. And if I have the square root of 3x plus 4, and we want to see if that's equal, or that is equal to 5. So what value of x there would make this a true statement, right? That's what we're solving for. So notice on the left side of the equation, right? On the left side of the equation, that radical is by itself, okay? There is no plus anything on the outside of the radical or minus anything on the outside of the radical. And when this is the case, once you have isolated that radical, what we do next is we square both sides. So we take that square root and we square both sides. Okay. We'll square both sides. So once the root is by itself, square both sides. Now we have seen that square cancels the square root. So we're left with 3x plus 4. And that is equal to the square of 25 means 5 times, the square of 5 means 5 times 5, which is 25. Okay. And now we have an equation we can solve for x. As you know, the next thing we'll do is -4 on both sides. When I do this, I have 3x. The +4 and the -4, we see cancels out, and that is equal to 21. And now to get x by itself, we will divide both sides by 3, and 3 divided by 3 divided by 3 is 1, so we don't write 1x. 21 divided by 3 is 7. So don't forget, we have to check. You must check, because you squared, right? This could possibly be an extraneous solution. So let's check now. Check, is x equals 7 true? Well, x equals 7 in the original equation, right? Must go back to the original equation. So the original equation we know is the square root of 3x plus 7. And is that equal to 5? Right, that's the original equation. 3x plus 4 equals 5. Oh, 3x plus 4. 3x plus 4 equals 5. Okay. So let's replace x. We will replace x with 7. Huh? So we have the square root of 3, and we replace x with 7. And we want to know, is this true? When we simplify the left side, do we get 5? Well, 3 times 7, if you multiply these, you get 21 plus 4. Yeah. And 21 plus 4 is 25. And 5, the square root of 25 is 5, is equal to 5. So this is true. So now we can say x equals 7 satisfies the original equation. So x equals 7 is the solution. Okay? So it is correct to say that x equals 7 is the solution, or what we say sometimes is the answer. Let's look at another example. If I say solve the square root of 4x minus 7, and is that equal to -3? Okay, so remember, we can't solve unless we get rid of the radical, and to get rid of the radical, you have to make sure the radical is isolated either on one side of the equation. So in this equation, yes, the radical is by itself. Okay, all you see on this left side here is a radical by itself. There is nothing out here, right? Like a plus or a minus anything. So if that was the case, you would have had an additional step to do. Okay. So to do this, we now square both sides. So the square root of 4x minus 7 equals -3. We will square both sides. By squaring both sides, that square and the square root cancels. So we have 4x minus 7 is equal to 9. And to solve for x, we're going to add 7 on both sides. And to do this, we have 4x, the -7 and the +7 become 0. We generally say cancel out. And 9 plus 7 is equal to 16. And to get x by itself now, we'll divide both sides by 4. 4 divided by 4 becomes 1. We don't write 1x, right? We just write x. So x is equal to 4. Now don't forget, you have to check, okay? And when we check, we go back to the original equation. So use the original equation, which is the root of 4x minus 7. And we want to know, is that equal to -3, right? So let x equals 4. Okay. So let's not put the question mark here. So we have the square root of 4, and now we're going to replace x with 4. This is what we want to know. Is this true? Okay. So 4 times 4 is 16. So 16 minus 7, the root of that, would that be equal to -3? Now 16 minus 7 is 9. and the square root of 9 is 3, okay? And we see that 3 is not equal to negative 3. So this here is not true, okay? This is false. So the solution, okay, x equals 4 produces a false, okay, statement. And this only happened if or because we square both sides. So x equals 4 in this case is an extraneous solution. Yeah? It's an extraneous solution. It will satisfy the equation that we squared, okay, but it does not satisfy the original equation. Okay? So in this case, we say that this problem has no solution. Our conclusion is no solution. So once you see it doesn't satisfy from here, okay, this is the important step here. We already know that it goes to this. Yeah, it does not satisfy it. There is no solution to this. Okay, let's look at another example. Solve. We have the root of 5x minus 1 okay, plus 3, and that is equal to 7. So if you look on the side with the radical, okay, if you look on the side with the radical, we have the radical, but now we have also a plus 3. And this is what I said, the radical here is not by itself. So before we can start, or you can try to isolate, to eliminate the radical, we must first isolate that radical, meaning leave the radical by itself. So what we do, okay, is we will remove the plus 3. Okay? And to do this, we first minus 3 on both sides. So we had seen some cases before when we have to leave things by itself, right? When we solve the absolute value equation, we had to leave the absolute value by itself, right? So this becomes now the root of 5x minus 1. This plus 3 and this minus 3 becomes 0. And 7 minus 3, that is equal to 4. Now, this is by itself, the radical is by itself. We can now square both sides. So now we can square both sides. So once one side has the radical by itself, we can square. So we have the square root of 5x minus 1. We will now square both sides. By squaring, we know that the square and the square root will cancel out, as we say. 4 squared is 16. We will add 1 to both sides. So we have 5x, the minus 1 and the plus 1 cancels, and 16 plus 1 is 17. Okay, and to get x by itself, we'll divide both sides by 5. Okay? And we know 5 divided by 5 is 1. We don't need to write 1x. And 17 over 5. Well, 17 over 5 cannot be simplified because 17 is a prime number. So now, check. Now we want to check this. So let's check, is x equal 17 over 5 a solution? That's what we want to check. So we go back to the original equation, use the original equation. You have to use the original equation. And the original equation we know is 5x minus 1 plus 3. And we want to know if that is equal to 7 when x is equal to 17 over 5. So we have the square root of 5, and we will replace x with 17 over 5. This is what we want to know. Is this true? Is that really true? So let's simplify this. We know that if we multiply, we see here that this will cancel out with that. Okay. So this leaves us with 17 minus 1. And we write a plus 3, and is that equal to 7? So 17 minus 1 on the radical becomes 16. And the root of 16 is 4. And 4, we leave with the question mark. 4 plus 3 is 7. 7 is equal to 7, so it checks. Okay. So x equal 17 over 5 is the solution. Once it checked, that's my solution. That's a 17 over 5. 17 over 5. So here, that's my solution because it checked. Okay, very important. Okay. Let's look at another example. So how about if we solve t plus 5 is equal to the square root of t plus 7. So remember, on one side of the equation, the root has to be by itself. Okay, we don't care on which side. So in this example, this root is by itself on the right side of the equation. So we can go ahead and square it. So if we do this, we have t plus 5 is equal to the root of t plus 7. What we're going to do, we're going to square the right side. But if we square the right side, we have to square everything on the left side. Notice I didn't square them individually. I squared the entire side. Okay. By squaring, this side becomes t plus 5 times t plus 5. And that is equal to, when you square the side with the roots, you get t plus 7. Multiplying out the t plus 5, or from up here, you could use the formula, which we know it's t squared. Okay, since this is a plus, we'll have plus. You take 2 and you multiply it by t times 5. All right? And then you square the last term also. So this becomes t squared plus 10t plus 25. And you will notice, guys, if you FOIL that out, as you say, okay? If you FOIL that out, you will get the same thing. So this is equal to t plus 7, right? Now, notice that this is quadratic. This is quadratic. And to solve any quadratic, you have to let it equal to 0. So what we have to do is bring that t and the 7, okay? We have to move these two things because we want it equal to 0. So it's your choice, whichever one you want to move first. So in my example, I'm going to move the t first. You could have moved the 7 first. It doesn't matter. When I do this, I have t squared plus 9t, because 10t minus 1t is 9t, plus 25. This plus t and the minus t cancel, and that leaves me with 7. Okay? And what do I do now? Well, it's not equal to 0, so I also have to subtract 7 on both sides. And by doing this, okay, we have t squared plus 9t, and 25 minus 7 becomes 18, and that is equal to 0. Okay. And now to solve this, here we have to factor. Okay. Well, sometimes it can't be factored, but this one can. And we'll come to different topics when it can be factored. Use the quadratic formula or completing the square. So by factoring this, we have t plus 3 and t plus 6 is equal to 0. And now we take each factor, t plus 3 equals 0, okay, or t plus 6 equals 0. Now we solve for t. So we'll subtract 3 on both sides. And by doing this, we have t, the plus 3 and the minus 3 becomes 0, is equal to negative 3. Or, on the other side, we'll minus 6 on both sides. And if we do this, we have t, the plus 6 and the minus 6 becomes 0, is equal to negative 6. So don't forget, we have to check, right? So we have to check t equals negative 3, okay? And we also have to check t equals negative 6, because they may both work, or only one of them will work, or none of them will work. So you have to check. And remember, we use the original equation. So the original equation for us is t plus 5 equals to the square root of t plus 7. Yeah. So let's see when t is equal to negative 3. T equals negative 3. So we have negative 3, okay, plus 5 equal to the root of negative 3 plus 7. Okay. And don't forget also we have to check the other one. Let's finish this one here because we also have to check when t is equal to negative 6. So don't forget that. We'll come back. Let's finish up this side of the checking. So minus 3 plus 5, when you combine these two, you end up with 2 equals to the root of negative 3 plus 7, that's 4, and the square root. So this is what we wanted to check, right? Is this true? So 2, the root of 4 is 2, so this check. okay? So we know that t equals -3 is a solution. This we know, okay? So let's check the other side. So we have -6, okay, plus 5, and we want to know, is that going to be equal to the root of -6 plus 7? Okay, let's make sure it's covered everything there. So -6 plus 5 is -1. So here we have -1. By combining these two, we end up with -1. And we want to know if that's going to be equal to this root here. -6 plus 7 is +1. So -1, is that equal to the square root of 1, which is 1? And this we know is false. Okay, this is not true. Okay? So this problem only have one answer. T equals -3. Okay. So we only have one answer for this problem. Let's look at more examples. I would like you to solve, or let's solve together, the square root of x minus 3 equals to the square root of x and then minus 3 on the outside. So notice that on the right side, the x minus 3, everything is under the radical. On the right side, only the x is under the radical. The procedure is the same, right? Look on any side of this equation, and once we see a radical is by itself, either the left side or the right side. So if you look at my right side, the radical is not by itself, right? Because we have a +3. On the left side, however, on the left side, the radical is by itself. There is nothing, a plus or a minus outside of the radical. So in this case, we can square the left side. So we have the square root of x minus 3 equals to the square root of x and then minus 3 on the outside. Okay. So we can square both sides. Now be very careful. When you square the right side, you have to square the entire side, okay? You can't square individual terms, the entire side. So that's very important. You must square the entire sides, okay? Everything, not individual. And that's what we mean here. Okay? So we know that this square will cancel, leaving with x minus 3. But what happens on that side? So this is really the square root of x minus 3 times the square root of x minus 3, right? And when you multiply that out, okay, if you FOIL this out, we'll get this times this, which is the square root of x squared, then this times that, which becomes minus 3 square root of x, then this times this becomes minus 3 square root of x, and minus 3 times minus 3 becomes plus 9. So we have x minus 3, so the square root of x squared is just x. These are like terms, so you end up with minus 6 square root of x plus 9. So notice when we square, we tend to like introduce another radical here, and that's okay. Okay, so now what we have to do is get that radical by itself and square again. Okay, so let's see. So move everything to one side except for the radical, right? So we have to move here the x, the -6, and the 9. Those are the things we'll have to move to get the radical by itself. So choose one and just get rid of it. So the first thing I'm going to do is let's subtract x on both sides. And by doing this, the plus x and the minus x cancel, so this becomes -3 is equal to this plus x and minus x cancel. And then we minus 9 on both sides now. And by doing this, -3 minus 9 becomes -12. And the plus 9 and the minus 9 cancels. Now, to get rid of that -6, since it's a product there, since we're multiplying, we will divide by -6 on both sides. And -6 divided by -12 divided by -6 produces a +2. And this -6 divided by that -6 becomes +1. Now we have the radical by itself again. So what do? Well, we square both sides again. By squaring both sides, we'll get rid of my radical. So we have 4 is equal to x. Okay? And here we have to check. And don't forget, when we check, we always go back to the original equation. We have to go back to the original equation. Okay? So use the original equation. Check if x equals 4 is a solution. So we have to go back and we have to check from the original equation. This equation here is the original equation, okay? So the square root of x minus 3 is that equal to the square root of x minus 3 when x is equal to 4. So the original equation we see is the square root of x minus 3. And does that equal to square root of x minus 3 when x is 4? So let's plug in x is 4. So x is 4. Is that equal to the square root when x is 4 minus 3? So if we simplify, 4 minus 3 is 1. Is that going to be equal to the square root of 4 is 2? The square root of 1, when you simplify this, you get 1. And 2 minus 3 is -1. So this is false. Okay? This is not true. Okay? False. So there was only one solution to check here. So then here, this problem has no solution. Yes? This problem, when we solve it, will have no solution. So very common that when you check, right, we introduce extraneous solutions, so we don't have to get a solution. Let's look at another example. Let's try solve the square root of x plus 1 equals to 1 minus the square root of 2x. So notice that on one side of this equation, the root is by itself. Okay? The root is by itself. So I can jump straight into this and square. We can square that left side. But if I square the left side, you know we have to square the right side. And don't forget, we'll have to square the entire side. Okay? We will square the entire side. So that square will cancel out with that root, leaving you with x plus 1. And this becomes 1 minus the square root of 2x times 1 minus the square root of 2x. When you FOIL that out, okay, as we did in the last example, okay, when you FOIL this out, you will get 1 times 1, which is 1. 1 times minus the square root of 2x will give me just minus the square root of 2x. Then the square root of 2x times 1 will be minus the square root of 2x. And then the square root of 2x times the square root of 2x will give me plus the square root of 2x, everything squared. So we have x plus 1 is equal to 1. These are like terms, so it becomes minus 2 square root of 2x. And then the square here will cancel with the square root, so plus 2x. Yeah. And then we have to isolate that root once again. So we start moving things. So the first thing I'm going to move, we can either move the 1 or we can move the plus 2x first, right? So your choice, the only choice, you either move this first or that. It doesn't matter. So I'm going to move in this example. Let's minus the 2x first. And if we do this, okay, we have x minus 2x becomes minus x plus 1. And that is equal to 1 minus 2, the root of 2x. The plus 2x and the minus 2x cancels out. So we have minus x plus 1. Now we're going to subtract 1 on both sides. And when we do this, we have left minus x. The plus 1 and the minus 1 becomes 0. Same thing, plus 1 and minus 1 becomes 0. So we're left with minus 2, the root of 2x. Okay. And now we're going to divide both sides by negative 2. Okay. So by doing this, we have minus x. We can divide both sides by negative 2. So we're left with the negative and the negative cancels out. So we have x over 2 is equal to, this becomes 1 positive. So we're left with the root of 2x. Okay. And now we can square both sides. If we square both sides, because the radical is by itself, right? So we have here, this becomes x squared over 4 is equal to 2x. Okay? X squared over 4. Now, you have a fraction here, okay? And to get rid of the fraction, you can multiply both sides by 4, okay? So notice if you multiply both sides by 4, okay, we can, so let's make a note, we can get rid of the fraction by multiplying both sides by 4. Okay. So keep in mind, if you do 4 times x squared over 4 equal 2x times 4, then this eliminates or cancels, so you have x squared is equal to 8x. Okay. And you could have done that also when you squared here. You could have squared both sides. Notice over here, you didn't have to divide by -2. Okay. So if you have negative x is equal to -2 square root of 2x, you could have also squared both sides here. Okay. So this will become a positive x squared, because minus x squared, let's write that out. This becomes minus x times minus x, right? Which becomes positive x squared. And then on that side, this will become a positive 4 times 2x, which becomes 8x. So you end up with the same answer. Okay. So that was something that you could have done. Right? Now it is quadratic. So if it's quadratic, to solve it, it has to be equal to 0. So we have to minus 8x on both sides. By doing this, we have x squared minus 8x is equal to 0. So it is quadratic, you have to factor. So by factoring, we'll factor out x. We have x minus 8 is equal to 0. So this means that x is equal to 0, or x minus 8 is equal to 0. Okay. Well, this one here is already equal to 0. So that's, we have to check, but now we add 8 to both sides. And we have x is equal to 8. So we have to now check. Remember, when we check, we always use the original equation. We must use the original equation. So we're going to check x equals 0. We have to check x equals 8. And don't forget, the original equation here is the square root of x plus 1, and that was equal to 1 minus the square root of 2x. Okay. So we have to check both of them into that equation there. That's the original equation. So if x is 0, we have 0 plus 1. And is that going to be equal to 1 minus the square root of 2 times 0? So let's finish up this one and then we'll check the other one. So 0 plus 1 is 1. Is that equal to 1 minus 2 times 0 is 0, right? When you multiply 2 times 0, you get 0. So the square root of 1 is 1. This is equal to 1. And this becomes 1 minus the square root of 0 is 0. So 1 is equal to 1. So this check. So we know that x equals 0 is a solution, right? That's a solution. Now let's go ahead and check the other side. So now, or the other solution, possible solution, x is 8. So I replace x with 8. And and we have plus 1. And is that equal to, when we plug this in, x is 8. So 8 plus 1, that's become the root of 9. We have 1 minus 2 times 8 is 16. So the square root of 9 is 3. Okay. And we want to know, is that equal to 1 minus the square root of 16 is 4. So we have 3 is equal to 1 minus 4 is negative 3. And this we know is not true. So in this case, this is not true, false. So we only have one solution. Okay, and that solution is x equals 0. That's our only solution here. So I cannot stress the importance of checking your answers. Okay. So let's look at one more example, and let's look at an example where we're not using square root. What happens if we have a cube root? The cube root of 4x plus 5, that is equal to 3. Okay. Now, if we have cube roots, same idea is that the radical has to be by itself. So in this case, yes, we do have the radical by itself, right? The radical has to be isolated. So if it is isolated, then if it was a square root, we square both sides. But in this case, it is a cube root. So what do? We cube both sides. We cube both sides. And the cube root will cancel, and that gives me 4x plus 5 is equal to 3 cubed, means 3 times 3 times 3, which is equal to 27. And now we solve. So to solve, we'll first get rid of the 5. So we'll minus 5 on both sides. Okay? We'll minus 5 on both sides. And when we do this, we end up with 4x, the plus 5 and the minus 5 cancel. And 27 minus 5 is 22. And to get x by itself, we will divide both sides by 4. And when we do this, 4 divided by 4 is 1x. So x is equal to 22 over 4. And here, this can be simplified. So x is equal to 11 over 2. Now, you can check this also, but we do not, right? We do not have to check x equals 11 over 2 because, okay, because we raised both sides to an odd power. Okay? To an odd power. So what are we saying here? Well, what we're saying is, notice I didn't square it, I cubed it. Okay, I cubed it. So we only have to check when we square, or if this was a fourth root and we had to raise fourth, or any even root, that's what we have to check. But it doesn't hurt if you want to check. So you don't have to remember this rule. If you want to check all of your problems, you can do so. Yeah? If you want to check all problems. So as I generally say to you, there are many more examples that we can try. And for you to become better at this, you should always try more examples on your own. Okay? So I would strongly suggest to you is to try more examples.